So, hello everyone. So, good morning, good evening, and good night, depending on your time zone. So, my name is Breno Miranda, and it is my pleasure to welcome you to the session Industrial Case Studies and Doctoral Student Research. So, this is the last session of AST 21 before the conference closing, and we'll have 4 presentations. So, please stick with us a little longer. Unfortunately, up to this moment, we don't have any of the authors of the first paper. It's a short paper, so I'm going to introduce the paper to you and then play the backup video, okay? So the first paper of this session is called the Continuous Test Improvement Model by Maximiliano, Emanuel, and Gustavo. So let me play the video.
Hello everybody, hope you all are doing great. I'm going to present briefly part of my PhD in computer science research, which name is Continuous Testing Improvement Model. I am the doctoral student, my name is Maximiliano Mascheroni, and then I have my PhD supervisors, Emanuel and Gustavo, and we all are from Argentina. So I'm going to talk first about the motivation I had when I decided to start researching on this. I've been working in different software development projects for more than 12 years in both quality control and quality assurance areas. I was really interested in continuous delivery and continuous deployment, and I realized that software quality for these practices was somehow overlooked. Secondly, automated testing is one of the most used approach for speeding the execution of the test. However, there are other issues caused by automated tests like flaky tests, test maintenance issues, UI tests which fail because of intentional changes in the UI. So automated test is not enough. Also, there is a lack of tools and frameworks for some testing types. For example, in 2017, I worked for a project where we built a large big data infrastructure. I read a lot of articles, journals, I watched conferences, videos, and I was not able to find any documentation, guide, framework, anything about what we were doing. And last but not least, continuous testing. So when I started to research on this, everybody was talking about continuous delivery, continuous deployment, continuous integration, but nobody was talking about continuous testing. So I wanted to see if the missing part of this circle was continuous testing. So the goal of this project, first we wanted to identify all of the problems in continuous delivery and continuous deployment related to testing, of course. We wanted to look for solutions, proposal, tools, frameworks related to testing. Then using all those solutions, we wanted to build a model, a continuous testing model, and a tool for supporting the model. And finally, we wanted to validate the model by implementing it in real software development projects. So the first step we did was performing a systematic literature review. So the goal of it was to look for testing problems and solutions in any type of continuous development practice in academic literature. For that, we used the following query. We ran that query in academic data sources like the ones that you can see in this slide, and we got a total of 665 results. After applying some inclusion and exclusion criteria, we got a final list of 56 results. So for the testing problems reported in the literature, we found that the most reported problem was a flaky test. Then we have other issues, important issues like big data testing, automated testing of dynamic websites, continuous monitoring, and then challenges with UI testing. But the most important issue in the literature is flaky test. Regarding the solutions for testing problems, we found many proposals and techniques like the ones that you are seeing in this slide. Actually, we found more solutions, but we only include in this table the most reported proposals. You can see there are well-known techniques like parallelization or test rerunning. The second step we did was carrying out a survey, because We have the most reported problems in the literature, but we did not have problems reported at the industry. So that was the goal of the survey, and we used a questionnaire that we shared through social networks and mail invitations. We got 287 participants, but as some responses were incomplete or inconsistent, we discarded a few of them and we kept 255 responses. Now, these are the testing problems that were reported at the industry. If we look at the bottom of the table, we see that the most reported problems are lack of good practices for automated testing in continuous delivery, time-consuming testing, flaky tests, and automated UI testing. We did an analysis between the reported problems in the industry and the reported problems in the literature, and we found this. So there are three main root causes of all of the issues, and the root causes are time-consuming testing, flaky tests, and lack of good practices. These three issues cause all of the testing problems we have found in both the literature and the industry. So we had the problems, we had the solutions, it was time to start building the model. The model is a set of well-structured practices to gradually adopt continuous testing inside an organization. It has 4 adoption levels called improvement levels based on other models like CMMI or TMMI, and each level tries to solve most of the testing problems generated by each of the root cause problems that we shown in the previous slide. Inside each level, the practices are grouped in verification and validation stages. We will see that later. Finally, every practice of the model represents a solution or a partial solution for a specific testing problem in continuous delivery or continuous deployment. So these are the improvement levels that the model has. The first level is called implementation because its goal is just to implement the different testing types into your project. The second level is called management. The goal of this level is to manage the testing process you have in your project. The third level is called reliability. The goal of this level is to face flaky tests so that we can increase the reliability of our test. And last but not least, the fourth level is called continuity, which goal is to reduce time-consuming tests and also to implement some kind of continuous monitoring to implement continuous improvement. These are the verification and the validation stages. If you are familiar with the deployment pipeline in continuous delivery, you will see that they are the same. Local verification, build, functional testing, non-functional testing, and user acceptance testing. This is an overview of a good practice in a model. As you can see, you have the title of the practice, you have the level, the stage, the goal of the practice, you have the problems that the practice solves, you have the requirements that you need to have before implementing the practice, and then you have the task for implementing the practice. So this is about CTIM. This is the tool that supports the implementation of the model. So you specify what is the level that you would like to target, and then the tool will guide you through the different stages and practices that you should implement. An appraisal team will mark each practice as satisfied or not, and at the end, you will get the results. The results are similar to the screenshot you are seeing here at the right. The tool also provides a corrective actions plan for the appraisal performed. You can see what are the things that you need to improve or the practices that are missing. So for the validation of the model, we have used an iterative action research method that was divided into two phases. The first phase was a theoretical interpretation of the model, and the second phase was a set of case studies. The case studies describe how the model was implemented in several software development companies or projects with different levels of maturity that are using continuous delivery or continuous deployment. So in the first phase of the validation, we got feedback from the experts. So from 17 participants, 14 stated that the model was a solution for the testing problems, and 3 of them partially agreed. Then, regarding the case studies, all of the case studies showed that the model can be used as a solution for the different testing problems. As our final conclusions, flaky tests, time-consuming testing, and lack of good practices are the most reported issues related to testing in projects that use continuous delivery or continuous deployment. The model was proposed as a solution for different testing problems in companies that use continuous delivery or continuous deployment. The model was validated using an action research method. We got expert feedback. We got feedback from the model implementation in real software development projects. And at the end, the results of the validation indicate that the model is a solution to the continuous testing problems that exist today. And that's it. Thanks for your time for watching this presentation.
Okay, so at this point, I guess the presentation has ended, and at this point, none of the authors appeared in the backstage yet, so it's a pity because you cannot ask them questions. And the next presentation, so the second paper of this session, should start in 1 minute or so. So at this point, I'd say that I'll move to the next backstage and see you all in 1 minute, okay? Talk to you soon.